All right, I'm going to do a quick video for 9.1b, writing exponential functions. Before we get into writing, I am going to just review one problem with graphing. So I'm going to do one graphing review. So remember that the general form for graphing an exponential function is y equals a b to the x minus h power and then plus k. So a is responsible for the vertical shift or stretch, so if it rises faster or slower, and then it's also responsible if it's reflected over the x-axis. And then b is the base, it tells me growth or decay, and then h and k is the shift. So if I look at this function over here, I have a shift of 1, -4, because remember the h always comes out as opposite the h, and the k is always the same. So the first thing I'm going to do is shift my entire graph to the right 1 and then down -4. Okay, this is growth because my b is greater than 1. So when b is greater than 1, we have growth. And when b is between 0 and 1, it's decay. So since it's not a fraction there, I have a growth function, so it should be rising. So remember, for the table, we're going to choose those same values every time. We're going to stick with the same one. So I'm going to go with -2, -1, 0, 1, 2. Then the y, what you're plugging in here in the middle is whatever your b is to the x power. So in this one, b is 2. So I'm going to be plugging in these x's to 2 to the power of x. So for example, 2 to the -2. Remember your negative exponent rules? You got to take the reciprocal. So that's going to be 1 over 2 squared, which is going to be 1/4. Then you have -2 to the -1. That's going to be 2 to the 1 over 2 to the first, so 1/2. 2 to the 0 is just 1. 2 to the first is 2. 2 squared is 4. Then the AY column, that we use the A that's out front here. In this one, A is -1, so we take the whole middle column times -1, which makes that a -1/4, a -1/2, a -1, -2, -4. And then I am going to cross out my middle column because I'm going to graph my first and last section there. It's using the parent function idea. So I need to graph all of these points from my shifted point. I'm going to treat my 1, -4 right here. That's like my new 0, 0, that point. So I'm going to be graphing everything from this. So the parent function starts at the origin. This one's been shifted to the right and then down. So it's going to look like this. Okay, so from that point to the left 2 and down 1/4. So this one's been reflected too. So it's still growing, but it's growing from right to left instead of left to right, because it's been reflected. So -1, -1/2, 0, -1, 1, -2, and 2, -4. So it's going to approach this line right here, that orange dash line, but never cross it. And then it's going to continue to go to infinity this way. So it's approaching this line. And remember that we call this one that's approaching here, we call that the asymptote. So it's going to approach it but never cross. So that is our asymptote. Remember that corresponds to whatever our k value was, which in this case was -4. Our range corresponds to that -4 as well. Since it's below the line, it's all down here, the outputs, it's going to be less than -4. So it's never equal to, because it doesn't cross that. And then the domain is going to be all real numbers, because I can plug in any x that I want, or the function continues in the x direction infinitely in either way. So that's going to be x is an element of the real numbers. So that's a quick graphing review. Now we're going to go and try to say, if I gave you 2 points, like say I gave you this point on the function and this point right here. So I gave you a point right here and a point right here. If I gave you 2 points on that curve, could you give me the equation? Could you go back and give me this function? So that's what we're going to work on. So we're going to be writing equations that are in this form, y equals ab to the x. So pretty more basic ones without any shifting. Remember, the parent function is y equals b to the x. It's growth if your b is greater than 0. So like 1, 2, 3. And it's decay if it's between 0 and 1, like a half, a third, 7/8. Then it's decaying. So in this first one here, we have a 1/3 as our b, so it's going to be decay. In number 2, 3 is our b, so this is an example of growth. Even though our a is negative, it's still growth. In number 3 here, we have a 1/2 as our b, so this is decay. And in number 4, they're making sure that you're paying attention because it has a negative exponent out here. And for a negative exponent, you will need to rewrite that before you can decide, and it must have a positive exponent. So remember, you take the reciprocal, which would be 2/1, to the positive x. Now 2/1 is the same thing as 2, so now this function is actually growth. So make sure that you look at it carefully, that you have all positive exponents before you decide if it's growth or decay. All right, writing the exponential function whose graph passes through these 2 points. So we have a function that passes through the points 1, 4, and 2, 12. So this should be, just based off my little sketch here, we should be writing a growth function. And we're going to use a system of equations. We're going to write a system of equations. And then we're going to solve with substitution, which we did with linear functions for sure. So this is my general form I'm going to use, and these are my 2 points. I have one xy and another xy. So I'm going to write a system of equations using those. So with the first point here, the first xy, I'm going to plug in 1 for x and 4 for y, and I'm going to get 4 equals a times b to the first power. So I'm plugging it into the highlighted equation over here for x and y. I'm going to do the same thing on this side with the second point. So I'm going to plug in 12 for y. So 12 equals a times b to the second power. All right, so I have 2 equations. Now it's system. I set it up left to right because I'm going to use substitution to solve. So in substitution, you have to get one of the variables isolated and then substitute it into the other equation. So I always choose a as the variable I'm solving for, which you should too. And I always choose the equation that has the lower b value. So b to the first in this one, b to the second in this one. So I'm going to solve the one to the left for b, or for a. So I'm going to solve for a by dividing by b to the first power on both sides. So that's 4 over b equals a. Now, wherever I have an a, I'm going to plug that in over here. So I'm going to substitute the a in back over here. So I'm going to have 12 equals, now I'm going to replace that a with this 4 over b, because that's what a equals, and then times that by the b squared. This b squared was a whole b squared, so I can put it over 1, and that might help you reduce this now. You can see that you have b divided by, or b squared divided by b. So that's going to reduce to just a b in the numerator. So you're going to have 4b. So b squared divided by b, you get b to the first left over 1. 4b. Then finish solving for b by dividing by 4 on both sides, and I'm going to get b equals 3. Just like in substitution, you need your other ordered point. So if b equals 3, I'm going to plug that back in over here and solve for a. So 4 over b is going to be 4 over 3. And that fraction doesn't reduce, so a is 4/3. Now I'm going to go back up to my highlighted general equation, and I'm going to replace a and b with the 4/3 and the 3, and that's going to be my answer. So my final answer here is going to be y equals a, so 4/3, times b, so times 3 to the x power. So y equals 4/3, 3 to the x power is my answer there. Okay, I'm going to do one more for you. Same thing. So we're using this is our goal here. If you think about this one, it starts at 2, 9, and then 4, 20. So it looks like it's growing as well. I forgot to verify that I did get a b that was greater than 1. So it was growth, like my sketch. So I just wanted to make sure here. Okay, so started out the same way. This is going to be xy. So in the first one, I'm going to replace 9 equals a times b to the second power. And then over here, I'm going to do 20 because xy, 20.25 equals a times b to the fourth power. Now remember I said to always solve for a. And then I always pick the a that has the lowest b value. You can do it the other way around. I think it just ends up being a little bit more complicated because we are always dividing then by b, and so you end up with b's in the denominator instead of the numerator, and it just makes life easier if you choose the one with the lower exponent. So to solve for a, I'm going to divide both sides by b squared. So I have 9 over b squared is going to be my a value. And then wherever I have an a, so I'm going to replace, nope, I don't like how that looks. But this value with this a over here. So I like to draw my arrows to remind myself too. So I'm going to have 20.25 equals, I'm going to replace that a with the 9 over b squared. And then that's going to be times b to the fourth. And remember, b to the fourth was a whole number, it wasn't a fraction, so I can put it over 1 if you want to make the simplifying easier. Because really this is going to be 9 times b to the fourth over b squared. And then b to the fourth over b squared. This is going to reduce to b squared on top. So you're going to have 20.25 is equal to 9b to the second. So remember the division rule, you subtract the exponents. 4 minus 2 is b squared. Then to get b by itself, I'm going to have to divide by 9 on both sides. And 20.25 divided by 9 is going to be 2.25 equals b squared. I prepared this time. I didn't bring my calculator, but I did the math ahead of time. Then to get b by itself, since it's squared, you will square root. And the square root of 2.25 is 1.5. And you're looking only for the absolute value of b here, so you don't have to consider the negative b. So you only need the positive square root here. Plug that back in on this side. So if I have arrows going both directions, I know I've done the substitution both ways. So that's going to be 9 divided by b was 1.5. So I like to bubble my answer there. That's going to give me my a. So remember that 1.5 squared was 2.25. And 2.25 fits into 9 really nicely. So 9 divided by 2.25 is actually 4. So that's my a. So then my final answer, remember you need to go back to your general equation that I highlighted up here at the very beginning. So you're going to replace your a and b but keep the x and y. So my final answer here will be y equals 4 times 1.5 to the x power. That is my equation. So it was growth based on my little sketch that I did of those 2 points first. Okay, that's all I have for today's lesson. Thanks for watching.